Now we've seen Pearson's correlation coefficient in action. What we want to do now is build a linear model. Now a linear model is a straight line. It tells us how changes in one variable affects the changes in the other. We can build a mathematical model. It is very easy to do in Microsoft Excel. Now here's the correlation sheet from our previous video. What we can do is go into this scatter plot. I'm going to select any of the markers and I'm going to right click and I'm going to say add trend line. And there we go. What we want is a linear, there we go, that's a linear model. And let's say display equation on chart and display the R squared value of the chart. Now that's a bit small, so I'm going to select those. I'm going to go to home and under my font size, I'm going to let's increase that to 16 so that we can see it. Let's move it across. And there we see our model. Y equals 1.9071 times X plus 3.8134. So 3.8 is my Y-intercept, my beta sub 0 hat in my linear model. And my 1.907, that's my slope. That's my beta sub 1 hat. Now, what do these numbers signify? Of course, X is our independent variable value. Y is going to be an estimate of the dependent variable value. So you give me any value for the independent variable, plug that into X, multiply that by 1.907, add to that 3.8, and you will get an estimate. And that estimate lies on this dotted line. That is our line of best fit. So with beta sub 0 hat, by that we mean if we plugged in a value of 0, now 0 times 1.907, that's just 0. So all that's left is the 3.8, so that beta sub 0 hat is the estimate for the Y variable, the dependent variable, given that the dependent variable value is 0. In many instances that won't make sense because whatever you're measuring for that independent variable, it might be age, and to have an age of 0 will not make sense to your model. The 1.9071, remember, well, that is the slope. It says for every 1 unit increase, whatever that measurement is, that unit of measurement is for our independent variable, for any 1 unit increase in that independent variable value, we're going to grow the estimate for the dependent variable by 1.9071. So let's go to our data tab. I'm just selecting any of the cells because I want to make a new copy. So that's Control or Command A to select everything, Control or Command C to copy. I see the marching ants. Let's create a new sheet. I'm going to say paste values, and I'm just going to go to insert and insert table. My table has headers. Okay, that's great. And I'm going to call it regression because we're going to do simple linear regression. So I'm going to select any of the values in my sheet. Then I'm going to go to data analysis, and what we're searching for is regression. I'm going to click OK. Now it wants the input Y range. Now Y, remember, that is the values that I'm trying to predict. That is my dependent variable. So let's select that. I'm just going to go from dependent. I'll select the name as well. Shift Command down arrow. That whole column is selected. I'm going to expand again. For X, remember that is our independent variable. Click on independent, Shift Command, Shift Control down arrow. So I select that whole column. Expand again. Now let's make sure I will have to choose labels. Let's say we want a confidence interval as well. And let's put the output range. Let's select that. I'm going to go for cell number E1. Now if we look down here, as a matter of interest, there's a lot of stuff that you can select. Just the residuals, the standardized residuals, the residual plots, the line fit plot. Let's go for a line fit plot. But please investigate those on your own. Let's hit OK and look at all the information that we have. Let's click between E and F just to expand that. Now here we see the R squared value, 0.87. R squared is the coefficient of determination on the interval from 0 to 1. If I multiply that by 100%, I can express that as a percentage, 87%. And what that is, it's the percentage of variation in my dependent variable explained by my model. So ideally we want that as close as possible to 1. We see our F statistic very large, 2038. That gives us a very tiny p-value for that F statistic. More importantly for us, we're interested in these coefficients. That is our beta sub 0 hat, 3.8, and our beta sub 1 hat, 1.97. Once again, we're interested in that independent variables coefficient, 1.97. That's the slope. That tells us for every 1 unit increase in the value of the independent variable, we'll get an increase in the estimate for the dependent variable of 1.907. We see the standard error there. We see that we can calculate our t-statistic for that independent variable coefficient. We see a very small p-value because we have that very large t-statistic. For our purposes though, what we're really interested is this r squared, 0.87, so we can say that our model explains 87% of the variation in the dependent variable. And the other thing that we're really interested in is this beta sub 1 hat. the estimate for the population slope. Now more correctly, we'll say that's an increase in the mean for that value, but for our practical purposes, that's how we will interpret that. As you can see, using Microsoft Excel, it's very easy to do simple linear regression.